Let's pick up an H. And we were working on just more practice with integration, right? So we're still doing a lot of U substitution. So as always with substitution, look for what can I make U that I then also see the derivative of within the problem? Or is there a way I can rewrite this problem or break this problem up? Thoughts? I'm going the route of U. Do we see it? What?
The bottom.
The bottom part?
The 1 minus x squared.
So if I make U the 1 minus x squared, the derivative of 1 minus x squared is going to be negative 2x. Do I have a negative 2x in the problem? And it's not even so much about the negative 2, it's do I have the x?
Wait, is it sine?
Yeah. Because, so if I make U sine inverse or arc sine, I saw some of you flipping back, what is the derivative of sine inverse? Times dx. And I'm trying to think, do we have a spot that we have the derivative there? So on page 390, you can look at the integral. So you can work backwards. I think you'd have to go back to your first semester notebook to have derivative of sine inverse. I'm not seeing it listed. But, unless you guys are seeing it and I'm missing it, but what we can use here is, if you look at your inverse trig functions, arc sine of u over a plus c, right? So that's saying that the derivative of sine inverse would be the 1 over square root of a squared minus u squared, except these are just basic in that this is a and that is u, right? There's nothing fancy going on with this one, I guess is what I'm saying. Okay? So in turn, this a and u is not part of my u substitution, it's part of the formula. Okay, so maybe I don't want that in there necessarily, but okay, let's check this out then. If I go and rewrite this, sine inverse x is u, correct? And then what do we have here? Square root of 1 minus x squared on bottom, and dx, that matches right up, doesn't it? So I'm just going to have u du that I'm integrating. What is the antiderivative of u? One half u squared. And then if you sub back in, because it's indefinite, so we don't want to leave it, 1/2 times sine inverse of x, quantity squared. I would definitely say you need the parentheses around the sine inverse of x, quantity squared, because I can't put the squared where the sine inverse symbol is. And if I just put it after the x without parentheses, that is sine inverse of x squared, as opposed to sine inverse squared. Okay? Yes?
Where is the 1/2?
Divided by 2.
Yes. So add 1 to the power. 1 plus 1 becomes 2. Divide by the new power. It's called keeping our derivative and antiderivative rules straight. Okay. Yes?
This is a little off topic, but is 2 a prime number? I don't think it
Yes,
is.
it is, because
Definition of prime is it has exactly 2 factors, 1 in itself.
any other even numbers.
Yeah.
It's the only even prime. It's the only even prime number.
Okay, that's what was throwing me off. I was like,
Yeah. What bugs me is when they throw 1 into these scenarios.
Oh, because
I always struggle to use the meme when they throw 1 into the scenario because technically 1 is neither prime nor composite.
Because it's just times itself.
Right, because 1 only has 1 factor.
One.
And prime numbers, the official definition is 2 factors, exactly 2 factors. And I don't know if it's specifically 1 in itself, but exactly, you know,
So what would 1 be considered if it's not?
neither.
Just neither?
Not prime, not composite. So,
Special.
special, there you go. Okay. So that was random, but valid. It was math conversation. Okay, are we good? Now we've got to find some definite integrals. Okay. So we're going to be evaluating. Same idea though. Thoughts on where to begin on A? Did I hear no?
Who said that?
I mean, keep going back to, you're looking for what can I make U, that the derivative is there. We often look for things within powers. We often look for denominators, you know. You want to try it? And here's the deal. Worst comes to worst, we try this and it doesn't work out. Then we backtrack. And I know I don't usually let you guys go too wrong here. You know, I might talk about it, but I don't let us go too wrong. But try it. If it doesn't work, try something else. Okay. So if U is x plus cosine x, what is the derivative? What's the derivative of x? 1. Derivative of cosine x? Negative sine x. And then officially it's times dx. Well, did that work out pretty well for us?
Yeah.
Okay. Jacob's being contrary today. Got it.
Just ignore.
Now, with that in mind, we have an option here. We can either change our bounds, because remember these bounds are x values, right? So we can either change the bounds from x values to u values, and then we never have to go back to x, or we integrate with our u, and then we have to go back and plug in x's later. Okay? So what we've been doing is changing. So if x is 0, then u is 0 plus cosine of 0. Cosine of 0 is 1, so u is 1. If x is pi over 2, u is pi over 2 plus cosine of pi over 2. Yeah. So I should have just stopped and written pi over 2, but. Okay, so it changed our boundary slightly, didn't it? So let's rewrite this. The integral, instead of 0 to pi over 2, it's 1 to pi over 2. Okay, what do we have? X cosine x is on bottom, so that is u. 1 minus cosine x dx matches up, so that is du. Antiderivative of 1 over u. Natural log of u evaluated from 1 to pi over 2. Because we changed those boundaries, we just get to plug in. Evaluate upper minus lower. Natural log of pi over 2 minus natural log of 1. What do we know? Natural log of 1 is 0, so we're just going to say natural log of pi over 2. Okay? And remember, a natural log graph, if it helps, there's your natural log graph. Okay? So, and that point being, not 0, 1, 1, 0. Okay, so there that's showing no negatives, no zero, positive values. Okay. B. What would you like to do? I'm assuming you want to go a U route. Go for that power of 2 minus x. And if you start thinking, I don't know, is it going to work? Well, always the question is, what's the derivative? What's the derivative of 2 minus x? Negative 1. So we have negative dx. A negative is fine, right? Because you can just switch that to the other side. So, integral. Oh, dang it. We're going to have a negative out front. And then it's going to be integrating e to the u du. My dang it is, what did I forget to do? Yeah, I forgot to change my boundaries. When x is 1, what's u? 1. 2 minus 1, which is 1. When x is 3, what's u? 2 minus 3, which is negative 1. Okay. Now, you have a choice. You can leave that negative out front, and you can work this as is, plugging in negative 1, minus, and then plugging in 1. Or, that's a lot of negatives involved. So, if we switch the boundaries, that means you multiply by a negative, except it's already negative, so it just becomes positive. And so you can rewrite this as the integral from negative 1 to 1 of e to the u. What's the integral of e to the u? E to the u. Evaluated from negative 1 to 1. So e to the first minus e to the negative first. I feel like I could see that answer most likely. If I get a common denominator, I could see that answer. I did magic, but it's common denominator magic. Do you follow the common denominator magic? E would have been, if you get a common denominator, e squared over e, right? Minus 1 over e, so here's the deal. You could get an answer that's supposed to be this, but they could put it in this form, right? So that is helpful to know with multiple choice answers. This is one, honestly, that could easily be done without u substitution, because when you integrate that, it's just itself, right? And if you're compensating for the derivative up there, the derivative of that exponent is just a negative, so it's just multiplying by a negative. So you just as easily could have said that this is going to be negative e to the 2 minus x evaluated from 1 to 3. And we wouldn't have to use u substitution. Now, are you ready for that? I don't know. I mean, that's a basic version, but just a thought there. Okay, moving on. Okay. C. It's a fun one. Thoughts? Pause and give you guys thought. If I just tell you, I don't know how much you're learning. Thoughts on what U is going to be?
X.
I would definitely try the 3 over x. Okay. If I look at, the only other option I could really see is x squared, but the derivative of x squared is 2x, and that I don't really see that helping. Now, what do we know about 3 over x? That is also the same as saying 3x to negative 1. And if we're doing the derivative, we're going to want to think that. So multiplying by negative 1 is negative 3, x to the, subtract 1, negative 2. Well, if I rewrite this, negative 3x to negative 2 is negative 3 over x squared. Does that give you a visual that helps there? Okay. Now, if you start thinking about what matches, here we're going to have our e to the u. We have x squared on the denominator and dx. What doesn't quite match up? The negative 3. So that negative 3 is in the numerator. So you're going to want to divide the negative 3 over. And so you could think of this as negative 1/3 du equal to 1 over x squared dx. Okay. And integrate. Oh, keep forgetting to change my boundaries. Okay, I'll get it in a moment. Negative 1/3 out front takes, let's see, x squared dx is part of my du. So I'm just going to have e to the u du, aren't I? Yeah. Okay. Boundaries. Well, let's see. When u, nope, it's not u. When x is 1, u is 3 over x. 3 over 1 is 3. When x is 3, u is 3 over 3, which is 1. Have you noticed every time our boundaries are upside down, she tends to have a negative out front? I don't count that as a sign. I've never seen that happen so much until these notes. I will say that. So
It's nice though.
it is nice, right? So in order to flip 1 and 3, if you want to do that, you multiply by negative. Multiplying negative by negative makes it a positive. So 1/3. Numbers way back, but it'll be a lot easier to plug into just e to the u than e to the 3 over x, and you know. Okay. Antiderivative of e to the u. E to the u. So then I'm going to say 1/3. I'm just going to leave that out front. I have e to the 3rd minus e to the 1st. You could leave it like that possibly. Interesting. So I was going to say you could put it as e to the 3rd minus e over 3. Like, these are all good options. That's an option. That's an option. I'm also looking, this had to have been what I saw in the answer key, because I would have done one of those two options. Notice e cubed minus e technically has a GCF, doesn't it? And so a variation of this option would be if you factor out the e, you could say e over 3 times e squared minus 1. That's a variation of, you know, I think you see it from that one better. Which, of course, then also leads us to have e times e squared minus 1 over 3. So many different options, right? Yes. No, stretching. Okay. And D. D almost looks too obvious. Or is it not obvious? I don't know, I can't tell where you guys are at. Is D obvious? No? No? More, go bigger. in terms of the whole denominator. And the reason we can use that whole denominator is because that one's just going to disappear when I take the derivative, isn't it? It'd be different if that one wasn't going to disappear, but it will. So derivative of 1 is gone. Derivative of e to the 2x. E to the 2x times the derivative of 2x, which makes it times 2. This is where I said it's almost too obvious because it works out perfectly. If I change my variables, when x is 0, u is going to be 1 plus e to the 2 times 0. 1 plus e to the 0, which is 1. So u is 2. When x is 3, u is 1 plus e to the 2 times 3. Yuck. 1 plus e to the 6th. But the good news is it'll be an easy plug-in. So, okay. Let's see. 1 plus e to the 2x is my u. 2e to the 2x dx matches up with du. 0 to 3 becomes 2 to 1 plus e to the 6th. Now, I wrote something differently just because. I wrote du over u. Huh? Uh-huh. And what I just need you to realize is that's the same as saying 1 over u du. There is no different. But here's my thing. I don't want you to freak out if you see du over u on an AP question. Okay, they're the same. It's just two different ways to write it. Just don't get confused. If you see a du on top, just pull it off to the side and then look at what's left. Okay? So, integral of natural log integral of 1 over u is natural log of u. And so we're going to have natural log of 1 plus e to the 6th minus natural log of 2. Does 1 plus e to the 6th need to have absolute value around it? Could 1 plus e to the 6th be negative? Okay. Well, e is a positive value raised to a power, and then you're adding 1 to that. So since that can't be negative, you would not have to have absolute value there. Okay. And so this is the scenarios where you see it sometimes, you don't see it all the time. Okay. Moving along. Bell rang and I totally missed it, didn't I?
Yes.
Okay.
What rang?
I guess. It's based on the clock it rang. I didn't hear it either. I don't know.
I heard it.
Okay.
I heard all the kids.
Well, and I must have been in the zone because I didn't hear it. It's not a bad thing. Okay. Huh?
If you didn't hear it, then it didn't.
Well, by timing, even if that bell didn't ring, the next bell's going to ring, and so I need to know when that is. Okay, I'll be happy if we can get through this page. Challenge page I can live with or without. Okay, thoughts on E? What'd you say? Uh-huh. Because the derivative of x squared is 2x dx, right? Bless you. When I start checking things, I have x dx, but I'm missing the 2. So 1/2 du is x dx. Okay. Keep forgetting to change these boundaries. When x is 0, what's u? Heard that bell. U is 0 then. When x is 1, what's u? 1. Now there's boundaries that didn't change. Okay. So it's still the integral from 0 to 1. X dx is going to be 1/2 du. And this is 5 to the u. Okay. I'll start us off. 1/2.
Is this one of the ones where it's a to the u though? Do we have to do that rule?
This is that rule that only like 50% of you have remembered. The others of you just keep ignoring it. So, okay, so the rule is the integral of a number base raised to a variable is 5 to the u over natural log of 5.
So do you only write it out in this step, or could you just like this is because it's the was it integration or whatever? Like when you write it out, that's the step you put it in. I don't know.
Yeah.
Okay, yeah, because that's
Yeah.
This is the step I'm taking the antiderivative.
Okay.
Is that what I need to say?
yes.
So like at this point, I was just rewriting it, and
Plugging in the u,
I'm
but-
plugging in my u and getting it rewritten out so I know what I'm integrating.
Yeah.
Yes, go take care of that.
I have never had a bloody nose.
Mine's would have not gone. I think I had my first bloody nose a couple of years ago, and I didn't know what to do with a bloody nose. I was like,
My
how
brother.
do I get this to stop? Like,
No, my brother gets him so easily. He can rub his nose and bleed, and then
Yeah.
I'm over here like.
okay, are we good with this then? Okay, so we are the 1/2. I'm debating which way I want to. I don't even know what I would have done here. We evaluate what? 5 to the first over natural log of 5 minus 5 to the 0 over natural log of 5. So 5 over natural log of 5 minus, what's 5 to the 0?
1.
1.
I taught my dad that. My dad had no clue that was a thing when I was doing the calc the other day. I taught him that, and he looked at me like I was on a different planet.
5 over natural log of 5 minus 1 over natural log of 5 is all going to be 4 over natural log of 5? Because that was a common denominator thing, yes? Final answer.
2 over ln 5.
So officially, you could say 4 over 2 natural log of 5. However, yes, that does reduce to 2 over natural log of 5 because, yes, you could cross cancel. Well, and I will tell you that I think this is one. When I went to check the answer key, I had 4 over 2 natural log of 5. I just overlooked it, and So,
Japan. I don't care.
okay, continuing. What you gonna guess?
Cosine.
It's in the power, so it sounds like a good thing to me. Okay. U is cosine. So what's the derivative of cosine? Negative sine x dx.
We're gonna have to flip flop
What do you mean?
because it's gonna be a negative. Okay, but it's her notes, not.
I mean, you can flip flop, or you can just know that you have to put the negative in later. Oh, I see. You're talking about, are my
Just-
boundaries going to have to? Probably.
Oh,
I haven't even thought that far ahead, but shocker.
yes.
Okay, now let's figure out our boundaries, though. When x is 0, u is cosine of 0, which is 1. When x is pi, u is cosine of pi,
Negative.
which is -1. I didn't understand what you meant by flip-flop at first. Okay, so we're going to have a negative out front. 0 to pi becomes 1 to -1. Cosine x is u, so e to the u. Sine x dx is du, and we have the negative.
Can I get on your sweatshirt?
I saw that as you walked out.
Take it to Carrie later.
You want a tight stick?
No, it's maybe next period.
I say,
He literally just whipped out a tight.
I have a tight stick in my drawer. So, yeah. I have, you know what I have in my drawer also it might help? Alcohol wipes.
Just alcohol.
This is sorry, miss.
Alcohol wipes! Oh my goodness.
Yeah, we're totally seniors over here.
So, want to try an alcohol wipe there? I don't know. I mean, if you take it to Carrie, what's she going to use on it? A spray version of alcohol wipe, right? I've seen them use alcohol wipes on stuff like that, actually. So, I don't know. Okay. Let's see. Where am I at? Antiderivative e to the u? Oh, you want to flip them. Okay. Valid point. Flip my boundaries. -1 to 1. E to the u du. Antiderivative e to the u? E to u. Evaluated from -1 to 1. Did we just do this?
We've had this answer before. It was number B.
Okay.
Or letter D.
Number D.
Number D.
Okay. So, e minus 1 over e is what I'm most likely to say. Okay. We have some time to complete the square today, which is good.
Oh no.
Right? Okay. Is that healthy at all, Megan? Or I don't know. No. I'd say. Okay. As we look at A, the integral of x squared plus 12x plus 37. No, you can't break it into 3 fractions. You can't break up a denominator like that, okay? That would, that's what I know. We kind of want to try that, but it doesn't work like that. This is a situation. You'll notice it says in the directions, evaluate by completing the square. In other words, think about that denominator here, okay? When we go to complete the square with something like this. X squared plus 12x. And then I'm just going to move my 37, well, I'm going to move my 37 down. There's a couple different ways I can do this. I don't know the best way to teach it, sorry. I'm just going to move the 37 down for a moment. I'll show you kind of a shortcut in a moment. But complete the square for me.
Isn't it B squared over 2?
B over 2 squared.
B over 2, quantity squared.
36.
So 12 divided by 2 is 6. 6 squared is 36. Now, in this situation, hold on. We add 36 here. This is all one expression, right? So how do you counter out an adding 36 when you're all on the same side of the equation in one expression? You're going to have to subtract 36 because we don't want to change the value of this expression. Now, the idea here is that you end up with an x squared plus 12x plus 36, which is our perfect square. And then 37 minus 36 is a plus 1, yes? I'm going to factor it next. If you look in the answer key on this one, they didn't really show the plus 36 minus 36 and how that came about. They just looked at it as, okay, if it's x squared plus 12x, plus 36 completes the square, and then what do I have left over is a plus 1. Okay? Now, anytime we talk about completing the square, the whole point of completing the square is the next step is to factor it. That's always the job of completing the square. Is because now this can factor. Square root of x squared is x. Square root of 36 is 6. And it's a plus 6 and a plus 6 to add to be positive 12. Right? How long has it been since we've completed the square? Has it been a moment? I think I've done it more recently with pre-calc than I have with you guys. So, okay.
I don't even know if we've done it at all this year.
I think we did it once in person.
Why did I just write du? Okay, now, doesn't really look a whole lot better, does it? By the way, I will write this up here in case it was b over 2 quantity squared is what we did, once we remembered that. Okay. This is one of the integrals, antiderivatives, we need to work to know. This is a variation of it. We did it once, I think it was the very last problem we did yesterday. Tangent inverse. So can you see this being a tangent inverse because it's 1 over, officially it says a squared plus u squared, but this is u squared plus a squared. So we have a variable squared plus a number squared. This is tangent inverse. Are we full of injuries in here today?
I went to like click the pen, like I click it, but I clicked the actual pen part and it got me.
So with this in mind, think in terms this is u squared plus a squared is what we're looking at, right? I'm trying to give you some notes here. So what is u and what is a? Yeah, I'm going to flip these. Well, u is x plus 6, a is 1. And actually, in this case, the derivative of u then is just going to be 1, right? I mean, you can think it, but we don't even really have to do anything with it necessarily because that derivative is just 1. In other words, we have all the information we need. We can go straight to our answer here. And this was back on that page 390 or whatever, right? Sounds about right. And so if you go back and look at that page 390, what was it? The integral of du over, I'm trying to remember how it was written. A squared plus u squared, right? There is a 1 over a out front, isn't there? Yeah. Tangent inverse of u over a. That's what you'd find back on page 390. Okay? There's your little helper. So when we do this, we're basically filling in this part here, right? 1 over a, well in this case it's 1 over 1, so it's nothing. Tangent inverse of u over a, so that's going to be tangent inverse of x plus 6. And then we're back to indefinite integrals, so don't forget your plus c. Did we kind of see that? Okay, so that's the idea when you see a complete the square, and you'll see some come across, okay? The idea is you're pretty much setting yourself up for something like a tangent inverse. Okay, you're setting yourself up so we have something squared there, plus another value. Okay. Shall we talk about B? As we look at B, if you try to use substitution, it's not going to get me very far. Because if I try u is 4x minus x squared, I'm going to have a 4 minus 2x as my derivative. There's no 4 minus 2x here. Okay? So we're looking at completing the square again. When I look at this completing the square, I can't work backwards. I have to, I don't know, maybe you guys can. At least as a teacher, I can't work backwards. I could work backwards on my own, but teaching it. So I'm going to flip this negative out front for a moment. I'm also going to factor that negative out, if you will. And if I factor that negative out, it's x squared minus 4x. Because what is one of our things with completing the square? The x squared term has to be just 1x squared, right? Before you complete the square, if there is any a value, you have to get rid of it. And so in this case, there's the a value of negative 1, so I have to factor that out. Now I'm ready to do my b over 2 quantity squared, which is 4. If I add 4 in the parentheses, yes and no. Yes and yes. I see, okay, so normally we say if we add 4 in here, we say subtract 4. But what is this 4 really multiplied by? And negative 1. So if you remember me teaching this earlier this year, I always say multiply by whatever's out here. And so thus, we're subtracting a 4 that is multiplied by a negative 1, so we really are adding 4. Are we okay with that? I'm going to keep that negative out front for right now. If I factor my perfect square, this becomes x minus 2. Square root of x squared is x. Square root of 4 is 2. Middle term is negative, which makes this negative. Now, I don't know if you guys have spotted what this is going to be yet. With this negative here out front, I would encourage you to flip this and say this is 4 minus x minus 2 squared. And if you think about it, when you look at the tangent inverse rule, it has the constant and then the variable, doesn't it? Okay? Obviously, we're not in tangent land this time, though. So, we're going to integrate. I'm going to rewrite this. The integral of dx over the square root of 4 minus x minus 2 squared. Have you spotted where we're going yet?
It's the sine.
It's the sine inverse. Okay. And if you go, I'm going to write it out up here. It's du over the square root of, I believe, a squared minus u squared, right? Yep. And it's equal to sine inverse of u over a. Again, sine and tangent, those are the two you need to be most familiar with. So, what do we know? What?
A is 4.
Disagree?
A is x minus 2.
Nope.
A is
2.
I wrote that down. On my
Well, it's not what you said, so I have to go by what you said. Okay. Can we agree that A is 2? For obvious reasons, because A squared is 4, and I think Jacob was really confused why I kept telling him no. He couldn't understand. And then U is going to be the x minus 2. This minus right here is a good thing, isn't it? Because the format of sine inverse is a minus right there. Notice, do we have any chain rule we have to worry about? No. The derivative of x minus 2 is just 1. No chain rule to worry about. Yes?
So if you got a problem where it was like 4 plus x minus 2 squared, what would you have to do?
Well, if it's not in a square root, I'd say it's tangent. If it's in a square root, I don't know. We wouldn't likely get one like that maybe because we don't really know what to do with it right now. I'd have to sit down and think about it. But that would be my thought. Is it's going to be set up to be tangent where it's adding without the square root, or sine where it's subtracting. Or it can be like this one, we can manipulate it around and made it happen. So, okay, did you guys write an answer? You're filling in this part, right? So sine inverse of x minus 2 over 2. Okay. What have I not written? Plus C. Did you guys write plus C? Okay. Okay, where are we at time-wise?
5 minutes.
I am not really sure. I am up to the challenge problem of challenge A. Oh, you know what? Okay, pause for a moment. Let's talk about tomorrow real quick. Tomorrow, you guys are on your own without me.
Yes.
I'm here during the school day, but I'm gone during 4th hour. So,
Do you not love us anymore?
my love for Girl Scout cookies is greater.
Chica, calm down, buddy.
Okay. So, no, all that to say, you guys know I'm in charge of the cookies for the troop. Our pickup time tomorrow is 11:25 or something like that. So, I'm leaving during 4th hour to go pick them up, take them back to my house, and come back. So, with that in mind, you guys know we're ready for review tomorrow, yes? So, jobs. We'll have to check this homework on Monday, I guess. And then, darn, the review. I was focused on getting Algebra 2 ready. You have a review in here, yes? And I will possibly, I haven't quite fully gotten through the review in here. And it's quite a lengthy review in here. I'm trying to finish getting through the review in here to decide what I want to proceed for sure with. Now, I will either find you guys during homeroom or decide, or I will leave them in the library is where you're reporting tomorrow. Okay? So, 4th hour calculus tomorrow, reports to the library, and your job is to work. Make sure your homework's done. Okay, technically that's still tonight's homework. And then start working on review. I will very possibly leave a review worksheet for you, because I have 2 options here. I have to decide what I'm doing. Okay? Sorry, I should have gotten a copy for today, but my brain didn't think like that until it was too late. Okay? So, that's how I want to use my last few minutes, I guess. Yes?
When's the test gonna be? I would prefer not Tuesday.
Yeah.
Physics. We have physics test on
And
Tuesday.
econ.
And econ.
I mean, like, econ's like whatever, but like,
Oh, yeah, we do have
It's
a physics
physics.
quiz on Tuesday. I'm guessing that's when you wanted it.
By the look on my face, is it that obvious?
Yeah.
In all honesty, I haven't done my lesson plans for next week, but Tuesday would have been what I would have gone with. I'm not going to be ready for Monday.
Talk to Mr.
If I want to push it as far as Wednesday,
Can you just
I'll
have
figure it out.
Kevin push the quiz
Yeah,
to
Mr. Kevin probably
Wednesday?
pushes the
Mr. Kevin can move his test. Just like talk to him. Have him push it to Wednesday when you have this on Tuesday. I'm
Give
totally
him some
fine
Girl
with
Scout
that.
cookies.
I would rather. I would.
I mean, and here's the deal. Whether I'm here or not tomorrow, what is the plan?
Review.
I mean, it would still put us on test on Tuesday, which is how this worked out perfectly, that I could, I'm like, oh, review day. You can work without me, you can make some progress without me.
I was
So,
I was-